Hi, Alex. Good morning.
Good morning.
How are you doing this
Yeah,
Friday?
I'm doing well. Start of a 4-day weekend. It's always nice to have those holidays. And exciting news, I became an uncle just yesterday.
Oh, that's awesome.
So yeah,
Yeah, thank you for joining us today. I'm glad to be able to get a conversation, I think, on working with larger data sets. I know that that's something that uh, we've discussed on various other live streams, but not necessarily a major focus. And it sounds like you've had quite
yeah,
a lot of experience on finding some of the intricacies and complications, and uh, I'm assuming will be some unique solutions to addressing working with them at scale, and also making sure that you're not paying for more than you need to be able to manage those things. But I think since this is
yeah,
your first time on our channel as well, I'd love for you to have a chance to maybe let the audience get to know a little bit about you and kind of who you are and what you do, if you want to give a bit of background.
yeah, absolutely. So I'm Alex. I work at Microsoft, but I work in one of our business units. I don't work on any product that you buy. Well, maybe. I work for Microsoft Advertising, which is the part of Microsoft that sells the ads on Bing and on Outlook and MSN and Yahoo and AOL and now Netflix. So, um, yeah, we're an ad sales business. And I run, well, the word "the" gets you into a lot of trouble at Microsoft because there's always other people doing the same thing you are. But I run a data platform that enables lots of people in our organization to uh, get the data that they need. Um, and so that's my job. Before that, I was a chemist and sort of stumbled my way into this data thing and into Microsoft. But yeah, um, cool.
Glad to hear a little bit more about kind of your role at Microsoft. I know as long as I've known you, you've been working for the company as well. I didn't realize you had actually
Hmm.
worked with Yahoo. I actually just I googled out of curiosity, like what's Yahoo's revenue still, and it's they still make multiple billions of dollars a year. So they're
Yeah,
actually like
yeah,
they. I don't think there is much publicly facing. I'm assuming if they make that much revenue, it's probably not from their search engine anymore. But I know they own a lot of other businesses.
yeah. So I don't know too much about Yahoo, but people still go to Yahoo to check their email, and there's a search bar, and they show ads, and
Yep.
I think it's quite a lot. But just to put some context on Microsoft's advertising business, in our last annual report was about $10 billion, which is to say it's bigger than Twitter, uh, Snapchat, Pinterest, and one other put together. You get to that fourth place, there's a lot of others. But basically, after Facebook, um, uh, Amazon, Google, and maybe Apple, like we're the biggest advertising game out there. Um,
Now
and so
I
people
have
are always sort of,
I was just
yeah,
gonna say I have a question for you. Is the considering that you do work with and around
yeah,
advertising, I did notice uh, somewhat recently from a post because I use Outlook Desktop, not Outlook Web, for
hmm,
for certain reasons. But it seems like that it's similar to how Google, where there'll be inline ads as it like that looks like an email that's built into the inbox,
yeah,
which Google's been doing that for
for years,
5
yeah,
years. But Outlook apparently has recently started doing that as well, where it's the it'll say ad, but one of the line items in your inbox will essentially be a row for like a clickable ad. But it is interesting that like so does most of the revenue for their advertisements come directly from like advertising to their customers internally like that, or is it more of the external ad placement from like Bing and other search engines from not necessarily Microsoft customers, but just people using their
yeah.
products in the web?
Um, that's a great question. So yeah, I did see something about us starting to do that. I don't use a Microsoft personal mail product myself, um, so I haven't seen it, but I, I did see something in some sort of deck in the last 6 months that made me think that was happening. Um, but most of the revenue, I mean, so I mean, I could talk about advertising for hours, and that could be a fun podcast. But basically, there's two
Yeah.
kinds of ads, right? There's display ads where they're trying to
Mhm.
get you to think of a business, and direct response ads where they're trying to get you to click on the ad and do something immediately. And most of our search ads, search ads in particular, are really all in that second category. So the buyers
Mhm.
for them have things you can buy. So Amazon, the big travel companies like Booking and Expedia, Walmart, like those are the super big ad buyers for the types of ads we have. Now in Outlook, in MSN, it's it's more of a mix. There's definitely people that just want you to see their name, right? The airport advertisers. Um, and then there's also these companies, and actually Amazon is in the bucket in this pile, where when you click on the link, you're going to see more ads. And what they're really trying to do is find some arbitrage where they can sell more ads than they'll pay for the click.
Yeah.
It works great for Amazon because you're also hopefully going to buy something, but they're going to sell an
Well, yeah.
ad, in the process. But like that's where you get sort of the seedy underbelly of the internet is when there's some property that doesn't have enough traffic or enough ad buyers to like fill with good ads. You get all these people trying to do arbitrage because everything's
Okay.
in auction. So if there's not much competition for an ad, then it doesn't cost very much. So
Yep.
anyway,
Okay. No, no. I think that was a nice little summary, and yeah, as you said, there's probably a whole podcast to talk about it. But
yeah,
the science and art to a degree of advertisement is an interesting one because a lot of it goes into human psyche and how our brain works and all sorts of other fun stuff. But some other interesting conversations for another day. But I do appreciate some of the
yeah,
context for kind of what you do and what goes on is certainly for the business. Now, before we actually get started with the lessons from a large model. There's also, as I do have a guest that's in the chat that we have a belated Christmas present that we wanted to give to
yeah.
you and show. So I'm going to go ahead and transition over here. But you are the latest data god of the week on the Kratos BI
Oh,
website. Yeah, so
that's exciting.
yeah, we have a page, and I'll drop the link for the people in the chat here in a second. I just want to scroll through this, but yeah, latest data god, nice little description and a cool little page built out for you with all of the fun pertinent details and everything here. So just wanted to, I was talking um, and managed to basically release this on the channel this week as a fun little announcement for you. So that would be a fun way to start the day today.
Very cool. Yeah.
Yeah.
Thanks, Chris.
Yeah, Chris, I'm sure you're in the chat, and I'll take a look there in a second. But yeah, thanks for the opportunity to do this. I thought this is a fun way to kind of usher in the new year. So,
Yeah, that is fun.
all right. So then I'm gonna drop this into the chat here, and then I think if you're ready as well, we can also get starting on segueing into the topic of the day as well.
Yeah, let's get started.
There we are.
Cool. So we did a little bit of an introduction, but that's actually where this presentation starts with like, hey, I work at Microsoft Advertising, which you probably haven't heard of, but it turns out it is one of the largest advertising businesses in the world. The other thing that's really interesting about it is that we are just like a little fraction of Microsoft, right? Like, sure, we're a lot bigger than Power BI as a business, but compared to Office and Azure, like, we're just a little fish in a big pond. And, that affects things like how the IT org works, right? Like, we're sort of off on our own. We're not using Microsoft systems. We're using Microsoft advertising systems. So let's talk about my team and what we do and our model. I saw someone put in the chat, how big are we talking about? So when I think of a large model, I'm really thinking of like 30 gigs plus. When I put this deck together, our model was 72 gigs. We've added with that top fact table, we've taken it and doubled the size of it. So I think we're in the like 88 to 90 gig range. When I put this talk together, I was thinking we'd get to 100 gigs by the time I gave it. But
One
doubling
one
that fact
point
table
one
wasn't as
billion
big a
rows
deal.
on your daily revenue. So okay, yeah,
Yeah.
So somebody dropped in just a minute ago. Let's see if I can actually quickly. Here we go. I want to put this on the screen. Just related to that billions and billions from Carl Sagan.
Yeah, yeah. And if you dig into this, like actually the rows, you know, and in the table view, the cardinality and the rows are the same thing, are not actually what's like such a big deal. I think the really big deal is that we have a lot of dimension tables. I mean, you can see we have 137 tables, and just a relatively large number. I mean, if you scroll down, if you look down past the fact tables in this screenshot, you see account attributes, current account attributes, client, advertiser, old customer, UCG. Basically, all of these dimensions have between 7 and 10 million rows, and with all of these different but similar dimensions, like our fact tables end up super bloated with big keys. And that's really what's driving the size here.
Yep.
And we'll get into that a bit later, but like that's sort of what I mean when I'm talking about a large model. And we'll definitely talk about that 100 plus dem tables and why they're there and why it's a bad idea. But for now, let's just talk a little bit about my team. My team is the central data warehouse team for our org. And so our goal is to sort of make everybody in the org successful. We don't build reports, we just build a data warehouse and an accompanying tabular model. So the goal is to make it easy for anybody to build reports without sort of taking too many shortcuts to make particular reports easy to build. And so while my manager and my second level manager own report building, like the actual project that I run that has a bunch of folks on it, including Chewy, who several people here might know from Twitter and other Power BI live streams, we just stick to data model design. So that's what's going on on our team. And as a result, we've sort of built up this massive model. And, you know, if you just let Power BI try to design the model diagram, this is what you're looking at, which isn't
And this is
isn't easy
why
to
we
look at.
have I keep calling them perspectives, which is not correct because that's a separate like named thing. It's
Yeah,
the
but
views
model
like
subpages.
thing model subpages like every single Power BI model that's built, unless you only have 5 tables, should always have subpages to explain pathways.
Yeah, yeah. And that's actually where we'll start with, which is I took screenshots of a couple subpages, and I'm just going to explain this design pattern because it will become really interesting as we get a little deeper into the model and what's going on. So we sort of have two main things going on. On the left, this is sort of the common pattern on all of the fact tables, which is there's this interesting thing that happens with slow changing dimensions. And maybe you've run into this before, Reed, but you sort of have this choice in slow changing dimensions where you can look at your facts based on your current attributes or your historical attributes. And they both have their downsides. If you use your historical attributes, you run into this problem where when you do period over period comparison, the category definition is different in each period. That might be good if you're trying to measure how the category has changed. But say you've got some internally defined segmentation, or you're classifying customers into verticals, and you want to know how has this vertical grown over the year, or how have my SMB customers grown over the year? Well, you probably don't want to be measuring how you've decided to change your SMB segment. You probably want to say, okay, give me one definition of SMB and let's compare those customers, former and initial, the same set of customers. And so just simply using the slow changing dimension doesn't, in my view, give you a very analytically valid comparison. So, but by contrast, if you want to measure sales attainment, you really need to put the customers in the right assignments in the right months so that every salesperson gets exactly the credit they get. And if they were only working on a customer for 3 months, they only get 3 months. That's also critical. And so the answer is you need to do both. So you often will see, I mean, this is basically like a type 6 dimension if you read Kimball, right? You have the current value and the value in that date for your keys. And that is nice, but then what happens, and this is why on this diagram here, you can see we have our current attributes broken out into a separate table. This is really helpful. It's also super bad, and we'll talk about why. But basically, this lets us say, hey, I'm filtering on advertiser. Do I want to filter revenue directly based on the attributes in the dates for advertiser, or do I want to activate this relationship and look at it based on the current advertiser to fact mapping? And so we have a little disconnected table that has labels for those states, and then all of our measures have a little is if selected value equals, then calculate use relationship, else just measure. And actually we have a little calculation group that helps out with that, which we will come back to. But that's a pattern that we use all over the model. The reason that we broke them into separate tables is that all of these attributes update every day. So if you're trying to do incremental refresh, if you put these directly on your fact table, well, now you're updating your fact table every day, which sucks. It turns out we still have,
even with incremental and using the real-time option of refreshing, keeping, let's just say 10 years, refreshing 15 days, real time against today's data. Does that still put in a large burden on it to put that? I guess at this model size, it's millions of rows, right?
It doesn't matter, because if a customer changes salesperson today, the current value has changed for all dates. And so you get a correlation problem where your changes are evenly distributed across basically any partition scheme you can come up with. And so, yes, you could do incremental refresh, but you basically have to have whatever your history is, refresh the whole history. So the partitions could help a little, but your refreshes wouldn't be helped.
Exactly.
So by splitting this out, now everything in this table depends on date. And so when a value changes, we don't have to go back and change the old dates. Now, there's a little bit of a there's a internal business thing that we have where, hey, the salesperson changed and it didn't get entered correctly. Well, it doesn't matter. The salesperson's got to be entered correctly. And so we allow our teams that take care of that to make changes to any of the relevant attributes within the entire half, so that at the end of 6 months, which ends tomorrow, when we pay out our salespeople, know it's right. And there's not a shucks, we didn't pay you correctly because we made a data entry mistake and we missed the window. And so we're actually refreshing 6 months of our data every day to account for that process.
Okay, because at any point, it sounds like, a status could be wrong, but there's also opportunity for them to fix it if they need to.
Exactly. Okay. Some of the other properties, for example, since it's an advertising business, a really big component of this is the agencies, right? Most of our large advertisers work with some kind of advertising agency. And for a long time, our assignments were driven by agency, and we could have an hour-long discussion on that topic. But when a customer changes agency, they don't always tell us right away, and so the customer properties are just like not always known at the time. Sometimes we have to like find out later. So
I do
so
have
anyway,
one. I was going to say one
yeah.
question just related to. I need to. Where did it go? Here it is. Perfect. All right, let me pop this onto the screen. So Chris wants to know, on high cardinality, slow changing DIMMs, how do you manage fact refresh and join performance?
Yeah. So that's a good question, and a little bit of a foreshadowing into where we're going.
Excellent.
I think Chris saw this presentation in Chicago. I'm not sure. He may have been presenting at the same time. But in any event, we'll start working our way there.
Okay, perfect.
So absolutely, the high cardinality joins are the bane of performance in this model. And so one of the first things that we did in the design of this model is this fact table. It has all of the keys for all of the many dimensions that it relates to on it. In the original version of this model, that was in a separate dimension. So the model was fully snowflaked. And so we had a like account month table that had a attribute for every account month and then a account month key. And the cardinality of that key was like 150 million. And it was really nice. It took our refresh correlation down even more because we didn't have this 6-month problem. It turns out that this design is just better. It's like 20 gigs smaller, queries are faster, everything about this design is better than having it be snowflaked out. But that wasn't where we started. We had to sort of test our way there, which is going to be the main theme of this discussion. But before we move on to this slide, let's just talk about what's going on the right here. This is another common pattern, although we mostly use this pattern on revenue, which is we have some dimensions. We roughly call them product, but that's not really a great description. That not everybody has access to. So, earlier Reed asked like, oh, like what about Yahoo's business? Well, understandably, there's some sensitivity about sharing how much of our revenue comes from particular partners. And in the case of a business like Yahoo, at various times in their life, as they've gone through merger and acquisition, drama, the revenue from us has been a very material amount of their revenue. And so if you have access to it, you might need to go on an insider trading list for Yahoo, even if you're not on Microsoft's. And so partner revenue is sort of sequestered off. And so this version of the fact table, which if we sort of flip back to this view, monthly revenue L2 is 700 million rows, is not accessible to most users. So you could do OLS, you could do RLS. If you do RLS sort of the normal way, people just wouldn't be able to see the total revenue. They'd only be able to see the revenue of the sort of components they're allowed to see, which would be Bing or something. But what we did instead is we did a DAX aggregation. So we basically took the built-in aggregations filter feature, we rewrote it using if cross filter, then X, with a switch statement. And so each of these fact tables has a separate measure on it. And based upon which dimensions you filter, we decide which fact table you have to query. Only some people can use this one. And then these are just aggregations. So like this is like 300 million rows, this is like 1 million rows, and this is like 100,000 rows. So in theory, this is a big performance boost. Now, this is an area we haven't done enough testing to find out whether it's really worth it, but these tables are sort of de minimis in their size and sort of filter context pre-storage engine query switch statements are really fast usually. So it's not a huge deal to have this complexity, like it maybe wasn't worth building it out, but we've got it. So we're gonna roll with it. But yeah, this is one approach to sort of fake dimensional security with the RLS that we have. So that's really common in the model, and that's why you sort of see, you know, a monthly table that's almost as big as our daily table. It's because it's got a whole other set of dimensions in here, and then that we just said, hey, at daily we're not going to support because they're too big. Yeah. So how do we make a model this large manageable? There's a number of things that we do. You know, when you talk about manageability, development is one big part. How do you refresh the model is another big part. And then, you know, can your users have a good time using your model? In our experience with Vertipack being so fast, refreshability is sort of the thing that sinks most people. And like most of the time, like you build a model, you build a feature, like, is this model usable? Refreshability is usually the thing where you run into problems. But we'll start with development. So you really have two options, because the third option is so bad that like you can't even really do it. So my option one is just only use tabular editor, right? Like you fire up tabular editor, you hit new model, and you deploy from there. And that's great. The big downside there is like writing Power Queries a little awkward. You either need to, you know, write raw M or copy paste from desktop. You know, maybe you use some of the plugins and Visual Studio Code to help, but it's not great, right? The other option is make a Power BI, a PBIX, and keep the data in it super small. You know, the option 3 I refer to in a second, which is like, could you know, having a super big Power BI, right? Just like have all the data in there, just, you know, open in desktop, try and hit refresh, work with it, and then you hit publish. And I found that works up to like 2 gigs, even at 500 megabytes, that starts to get annoying. And so we try and keep the model size in desktop super small. And, you know, to sort of give an answer, this is what we did. And we did it for I think some silly reasons, but also like Tabular Editor 3 didn't exist yet. You know, PBI tools didn't exist yet. Like we basically were just using ALM Toolkit. You know, when we launched this model, large size models and the XMLA endpoint were right on the boundary between public and private preview. We were some of the very first out there at this scale. I think if we were starting over now, I'd say, hey boss, we need Tabular Editor 3. This is the only way we're doing it. I still have plans to go to Tabular Editor 3, but you know, we've had new PO crackdowns the last year due to various economic things, so I haven't been able to get it done. Also, like if we're gonna do Tabular Editor 3, I really want to like go all the way with branch development and like the whole 9 yards. And that's
it's the only tool to allow for like actual true DevOps and CI/CD and everything.
Yeah,
like,
but like
especially for a model this big. Yeah, well, no, like that's a massive migration. And redo. Like you're going to basically have to, you know, essentially duplicate this model and then, you know, redeploy it. Yeah.
Yeah, so there's a question in the chat from Tenacious, and I also see Matthias's question. We will get to it. But Tenacious asks, like, is Microsoft not shelling out for Tabular Editor 3? And the answer is Microsoft is not one entity. We don't have a central BI function. And so it depends by groups. I'm quite sure there's at least one BI team in Microsoft that has bought Tabular Editor 3. In addition, the Tabular Editor 3 folks have given the Power BI cat team, at least, and probably some of the Power BI development team, free licenses to Tabular Editor 3. But sort of each organization has to make their own decisions and buy the software. So yeah, like if I wanted to get it, I'd need to get, 10 of their most expensive licenses. So like that's, $10,000 a year or something like that. That's not like, I can totally get POs for that. I spend more money on logging, but well, maybe not. Logging is cheap, but like
That's
it's
what
very
I try to tell
easy.
any of my clients. Like
Yeah,
it's crazy where people are like, oh, $10. I'm like, how much are you paying me per hour right now to like
right,
to build you this model? Like this is pennies on the dollar
right.
for some of those. But a lot of people I feel like subscription based things they're a little hesitant on because it's like, oh, like I can't just buy this. I have to pay. Like, well, yes, but you also get you know continuous updates and all this other stuff. But I don't know. I found that's the hardest conversation for people to buy into
Yeah,
is, and especially anything government or large company, like, oh, there's so
yeah,
many forms and hoops we have to jump through to be able to like approve this. This isn't just a one-time check. This is a recurring payment, and that's a whole different type of
yeah,
approval process to do recurring versus a one-time
yeah.
check.
For us, like the amount of money almost like doesn't matter. Like I can get $100,000 as easily as I can get $1,000. The 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 challenge is like, okay, it's software. It's got to go third-party software review. It's got to go through competitive software review. I have to get the PO signed off on, and oh, by the way, we're in a PO freeze, so I can't get any new POs until the economy looks better. Like
Yep,
it's not so much how much it costs, it's that I have to buy it.
exactly.
Um, but I've had opportunities to buy it. We've bought other stuff. Like I think we just managed to get Zebra BI finally across, even through the freeze. We'll see. Um, but like the bigger thing is like, hey, if I'm gonna switch to Tabulator 3, I want to set up CI/CD and all this stuff, and like that's like a
Mm-hmm.
3-month project, and I got to weigh that against my roadmap. And also, we're working on adding a bunch of that stuff to our data warehouse, which could be a fun presentation, but we'll sort of skip that. So we have a PBIX, but we got to keep it small. We can't have a 70 gig PBIX, even on my fancy gaming computer. Like it's just not going to work. And so the real way to do this is to set up a parameter and then put a filter step in all your big tables that basically just says, hey, if this parameter is set to 0, then pass through the entire table. Otherwise, filter to whatever you set the parameter to in terms of top number of rows. And this plus incremental refresh, we usually set this parameter to 10. So we just have 10 rows per table. And all of a sudden, you've got a 1 meg PBIX. And it's super easy to work on. I mean, when you have 1,000 objects in the model, it takes it a
Mm-hmm.
long time to do stuff, but like it's so much more pleasant.
This is also the
Um,
only way to use Power BI Desktop and deploy a large format data
yeah.
set to the service because Windows has a 10 gigabyte limit for files, right?
Yeah, I don't know that if it's Windows or the Power BI service, but yeah, if you try and upload a file over 10 gigs, it'll fail out.
Yeah, and
Um,
I think it's like an Office limit or something. Like you just can't have an Office file greater than that or
oh,
something. Yeah,
yeah,
the actual like the zip file format that is used for PBXs or PowerPoints or Words or Excel. And I'm sure there's like nuances to that, but like that there's a limitation to that. So it's impossible to have
yeah,
your file, your model in a file. So that like it's not only this is like it's not only a benefit but a limitation of just working in desktop. And then
yeah,
with deployment pipelines, you have the really easy ability to change those parameters from dev to prod, which is actually what I love about deployment pipelines with working with large data sets
yeah,
like this. Just work
yeah,
with a million rows, and by the time you get to production, turn the filter off essentially, and in Power Query, and then get your billions and billions of rows that you can pull into here.
yeah. I totally agree. I think that this is worth doing even once you get up to 500 megs. Like, I mean, it depends on your computer, but like on my business laptop, like over 500 megs starts to slow down. Um, on my old laptop, like anything and running Power BI and Teams at the same time would
Yeah.
start to slow down. Um, but definitely highly recommend this. The other big thing about this is whether you're using deployment pipelines or publish, you've got this problem where when you push the model over, it wipes out all the data and you have to refresh the whole model. So if you use, you know, if your refresh takes an hour or 4 hours or 8 hours to do the full pipeline, if you hit publish on your model or in your deployment pipeline, and last I checked, you're taking downtime until you've refreshed all those historical partitions, which for me is not really acceptable. And so what we end up doing is using ALM Toolkit to push over the deltas without wiping out the data. And then we only have to refresh impacted partitions and impacted tables. So Chris
This
in the
is a
chat asked,
quick mini
yeah, go
plug.
ahead.
So ALM Toolkit, fantastic tool. Christian Wade, who I don't know he's a program manager. I can't say his exact role, but he built that out, and I just did a quick link drop for anybody who wants to watch the live stream that I did with him last year that digs into that on more detail. But it is a fantastic enterprise model tool, and I'll just leave it at that summary for now.
Yeah, absolutely. We've been using ALM Toolkit the whole time. It makes a big difference. You can save like templates, so you can, like, for example, we've got this parameter in the PBIX, we want it to be 10, and prod we want it to be 0. So we can save a template that says like never overwrite the parameter, and then you open up the template and it does its comparison, but it automatically sets the parameter as don't update.
So quick question from Chris, but like I think as you're already mentioning, is like so this entire thing is still just a PBIX file, but you're using parameters to manage it, and I'm assuming still using external tools with it, but its core model is still just a PBIX rather than say a BISM or something.
Yeah, that's right. We have a PBIX that holds the model. We use Tabular Editor to edit the model. We use ALM Toolkit to deploy the model. But by having the data in Power Query or in the PBIX, we also get a Power Query external tool because it's only part of the Power BI layer. If we used a BIM file or a serialized folder format, and that really needs a name, but like there's no easy way to like throw a Power Query on to add a table that way. And it's just sort of, we talked about before, like that's where we started. But yeah. So at some point we'll go to saving them as a .bim file, but yeah, we won't there. The other thing that wasn't possible when we built out this model was you couldn't do user impersonation in an arbitrary report or like in Dex Studio. You had to go into like test as role in security. So if you didn't have a report associated with your data set, you couldn't do RLS testing. In the published PBIX, we have a little silly report that just like has some visual tables to help us do RLS testing. So now, you can impersonate in Dex Studio, and well, you can impersonate in the XMLA endpoint, and Dex Studio is really the best way to do that. And that makes it way better. But again, we haven't evolved our process since that became a possibility. So deployment, as we sort of talked about a couple times now, refresh is really the big thing, because if you're refreshing your historical partitions, you're taking downtime. And that might be acceptable to do overnight, but like our business is global. I've got my most important report developer is in Sydney. My dev team is in India. A lot of my users have contractors in India. We've got a big office in London. We've got a big office in New York. Like, this model needs to be available around the clock. There's certainly off hours, but Like just having it have incorrect data for 4 hours while I refresh historical data isn't really an option. So yeah, in the original presentation, I did a demo with ALM Toolkit. We might come back to that, but in this format, one, because we're going long because we've been chatting a lot, which is great, and two, because you're on YouTube. If you want to see an ALM Toolkit demo, pretty sure Reed's got 3 or 4 videos on it that are pretty good. And we'll just skip the demo today. So we've talked about this before, but now we're really going to dig into it. The biggest limit on model size is not really the size of the model. I mean, it might be if you're hitting up against the limit of your SKU, but I'd say at each of those breakpoints, when you go from 1 gig to 10, when you go from 10 gigs to 25, when you go from 25 to 100, and now with my team, we bought an A8, which is equivalent of a P5. So we have 400 gigs of RAM. But the model's still only 100 gigs because turns out refresh time is like way harder than just like stuffing more data in. And so we spend a huge amount of time working on that. So there's a number of things you can do right at the start to make things fast, which is to say the best thing you can do is not have Power Query do any work. Power Query, you know, if you go and you read up on its history, it was invented as a meta query translation engine, not a data transformation engine. So while it can do transformations and like, but it's not like, you won't find anybody out there telling you that like the reason we love Power Query is it's because it's really fast at doing joins. Like it turns out that's not what it's for. It's for talking to 1,000 different data sources and combining them together. But that's not what we're doing here. If you're building a model this big, you've got a data warehouse and or at least a database. And what you really need to do is build your database to look exactly like you want your Power Query to do, or your Power BI model to do. There's a number of great reasons for this. For us, a really big benefit of this is that there's a whole bunch of things our users want to do that Power BI is super bad at. Give me a list of all the customers and these by these metrics. You know, I need to export this data and give it to a partner. There's a whole bunch of stuff that Power BI just like throws up on. Because of its, you know, super cool compression, if you're basically asking it to reverse that compression and go back to the row level data, you're fighting the query engine. So having the exact same schema in the data warehouse makes it really easy for our users to go back and forth between the two. They can use the tabular model as a tool to explore the data warehouse. They can find exactly what they're expecting to find in the data warehouse. So we really strongly think that you should have in your data warehouse, which is accessible to your users, and a whole nother presentation on that point, because I know that's controversial, but materialize your data exactly as you want it in Power BI. Build the keys, build, you know, whatever. And Reed, I agree with you based on what's going on in the chat. Like, I'm not saying nobody should use Power Query. I'm saying when you're trying to build at this scale, like, you really got to set it aside. I help my users with Power Query all the time. I also generally encourage them that like, hey, we've got this SQL environment and you should give it a try. Here's a presentation I gave on how to get started with SQL. Like, you know, I've done SQL 101 presentations multiple times in our org to try and get people going, but also Power Query is super easy.
And I think that's a big thing too. Is, I mean, like I can read and translate probably not 80-90% like a SQL views that I'm that I can come across and give enough time, I can pretty much write any one of them and somewhat
Yeah.
optimize it. But also in that same amount of time, if, especially like let's just say flat files, because those are always crap. Like there's always a
Yeah.
lot of bad data with flat files. The
Yeah.
amount of how quickly I can transform and get that data correct and in the right shape in Power Query is so much faster. But
Oh,
I think there's an inverted curve. By the time you normally get to a model this large, usually there's also dedicated engineers and other stuff who can spin up views in a database to keep it in. But for
yeah.
I would say SMB individuals who like they have a database, they have a DBA who can manage it, but this person also isn't like a SQL master who can give you a view in 24 hours. It's like, all right, I need the data to look like this. That's 2 weeks. You know, give me 2 to 4
Yeah.
weeks. So the agile part comes into play on that. So I still build a lot of models for smaller businesses that are mostly managed in Power Query, and I do try to push it upstream as much as possible. But that upstream push
Yeah.
might be 4 to 6 weeks before I get that view back. So Power Query is a great tool to
Yeah.
allow you to at least get the data today and maybe push it upstream in version 2.
Yeah, absolutely. That's another good little tangent. If you listen to Rob Colley's podcast a couple times recently, he's been talking about the pipe's first approach to Power BI develop, or Faucet's first approach to Power BI development, which is like get the thing you want and then start mucking around with the data pipelines afterward,
Mm-hmm.
rather
Yep.
than trying to like put all your plumbing in place and then hope that you've got everything right. And I really like that. And and generally that's what I would recommend. On the flip side, um, like when we're talking about a 100 gig model, like we're talking about something very different, which is
Yeah.
like we haven't really talked about cost, and part of it is that like cost is super dependent, and like since I'm getting some internal uh discounts, like it's hard to compare, but like this is not cheap. Like building this model, like it's I also have a data warehouse, but like I have multiple developers working on this. Actually, I have multiple PMs working on this. And we just have the one model, Power BI model. One of our internal, it's become a bit of a joke, is that I'll ask this question in a meeting. It's like, is now the time where we need two models? And like, what axis should we split the model on? And actually, there was a question on in the chat about this that I want to sort of come
Yeah,
back
I
to.
have a couple that I just queued up. Just
Yeah,
if we actually want to take a minute just to,
yeah, let's
so
do that. Let's do that.
this one's a quicker and easier one, so I'll just start with that. But I'm just going in the order of oldest to newest. Are
Yeah.
there any direct queries in this model?
Yeah, so today, no, we did very intentionally design our model to support composite models. So all of
Mm-hmm.
our dimensions are in dual mode. That's really easy for us to do because
Yep.
because of this first materialize your data in your database exactly as you want in Power BI. All the things that would make dual mode difficult, we don't do because of that principle anyway.
Yep.
But one of the things we found out early on is that if you have a dimension in import mode and you want to switch it to dual mode, it's a huge pain in the butt. And so we just made a rule that's like, let's just bring everything in dual mode. So if we want to add direct query, we can.
Dropped a link in the chat just on Reza that talks about what dual
Yeah,
mode is for people's
yeah,
learning. But yeah, I think between either dual mode or now, honestly, like my favorite form of direct query, because it sucks against a large table. Yes, you get real
yeah,
data, but the performance is so bad compared to
right,
like the import. But that hybrid now with incremental refresh, where you can have historical, current refresh plus, let's just say if maybe a couple million rows or less of the actual like current data tacked in on the end in those 3 different modes, I think is such a like the performance of that is crazy good compared
yeah,
to a direct query against that original table.
yeah. I really like that feature. We don't use it because our upstream revenue recognition pipeline has 36 hours of latency to it. So it doesn't really make that much sense to try to pull that data in more than once a day. And in fact, upstream, our upstream partner has a daily cadence. So yeah, I do have, and like the reason we have dual mode is I do have some ideas on how we can add some crazy direct query on super big tables to sort of mimic the trillion row demo, because we do
Yep.
have like these billion row fact tables are already highly aggregated. The unaggregated version of them is trillions of rows.
Yeah.
Our raw monetization record or raw transaction log for the search engine, has a row for every click, impression, bid, like every search. Like it's billions of rows per day. We had an archive of some data we'd pulled out of it, and it was like 2 petabytes. And I had to go to my dev team and be like, "You guys got to get rid of that. It's costing us too much
Jesus.
money
Yeah.
to store." Um, and that was just like a small fraction of this log. So like, there could be some cool stuff to do there, but we don't do it anyway. Let's flip over
Two
to
other,
the.
yeah. I was just gonna say two other questions just to quickly catch some of the chat. Some Tenacious Data was asking if you're using data mesh and what is it in that case?
Yeah, so that's a whole other topic. We
Of course.
are not doing data mesh. I have a feature sort of in slow development. Features or we are implementing a number of ideas to how we build our data warehouse that have been somewhat inspired by data mesh. Basically, the idea of data mesh, it's like a data lake thing. It's not really a Power BI thing. Is, hey, you've got 5 different teams that are producing data, and you've got some structure for them to produce all of their data in the same standards. So rather than having the central BI team own the support fact table and the revenue fact table and the like sales pipeline fact table, you might have 3 different BI teams owning those tables, or 3 different teams. They might not be full-time BI teams, and having some sort of contract expectations so that they can sort of produce something that works together. It's a super big topic. I think there's some cool stuff there, but yeah.
And last question, and I think this is actually a good one. So the
Yeah.
surrogate keys. Do you use these in a model this big, or do you still use natural keys?
Yeah, so that's a great question. Surrogate keys, we do use a lot of surrogate keys. We do only use integer keys for our joins, although when you dig into it, they don't make that big of a difference. It's more of a style guide thing than a
Okay.
like in the Power BI side, what kind of key you use doesn't matter that much. In the data warehouse, having your keys, have certain characteristics, make it easier to ensure consistency in data.
I have had a couple of models where, like, I mean, I essentially, indexed and created my own set of integer keys, because the database that they used had like a 40 or 60 character wide hex key, which is just like any, like, looking at they had millions of values. I think maybe tens of millions, but it's like they did not need a string nearly that long, and it was adding a lot of file size because it was a unique key per row. So I think I shaved, like, I don't know, 20% off the model or something like that by converting it. So
that's totally a good thing to do. What we've found is that makes that column faster. If it's participating in a join, that doesn't really make a difference.
Sure, yeah.
Because Power BI is doing the dictionary encoding, it's actually doing the joins with its internal surrogate keys no matter what.
Yep.
Making the column smaller can make a big difference, but it's not really about the fact that it's key. It's just about the fact that it's a big column.
It's only a model size key. Like, the performance of, like, the visuals and the DAX won't change at that point. It's just
Absolutely.
It might refresh slower, especially if you're trying to do that in Power Query versus a view.
Right.
Like, I will say that's one thing that, like, try to avoid at all costs is if you actually are taking a fact in a dimension table and replacing something with a surrogate key with let's say you use the index function or something and have to join the 2 tables back together to map, like, that actually that will murder the performance, but you might save some file size, so it's a double-edged sword.
Yeah, that's totally true. I will say, once you get out of working in desktop and into a thin model, working with tabular
Hmm.
editor, one of the sort of central design paradigms in Power BI or like in tabular models that I think about is what you're doing is you're spending RAM to save CPU. You want to make your queries as fast as possible, and what you're doing is you're spending RAM to do that. And so anytime, like, making the model smaller is not an end of itself. Like, it can be nice to do. It definitely often results in faster queries, but like the like in our model, we've got some, like, for example, we don't compute new customers in real time. We have a whole fact table that just flags each month which customers are new, which customers are active, which are performing. You could do that by analyzing the revenue fact table, but it's faster to just pre-compute all that. And so, inefficiency isn't great, but like we really try to focus in our testing on finding the like what is causing us the most performance issues, and then let's spend CPU to go there. And so we sort of moved slowly through this presentation, but that's actually the real thesis of this talk, is you have to test everything. At a model this large, like the things you read in Marco and Alberto's book, like they might be right, but you're starting to get into an edge case. Like, you actually have to test what's going on. Also, one of the things we found is you read the Definitive Guide to DAX or one of the other books, you think you understand the best practice, you implement it, and later you come back and you test some alternate approach, and it turns out that was actually what the Definitive Guide to DAX was telling you to do. Like, you may think you understand what the book says, but you need to read it multiple times. And so, yeah, read. We're coming up on the hour here, and we've had a
We don't
lot of
have to
great
have
conversations.
yeah,
So
yeah, and we
if
don't
you want
have
to,
to do a hard stop. So I will say
great.
that if you have a little bit left, like I mean, if we go 10 or
Oh
15
yeah,
over, that's totally fine.
yeah. I'm game to go for a while. So, because I want to answer Alex Powers' question.
Oh yeah, yeah.
Or more importantly, I want to talk about Alex Powers' question and what it means. And
Let's
and
say then just
yeah,
for time ticking, let's plan between about 10:15 to 10:20 somewhere in there
yeah,
to have the wrap up. So another 15 or 20 minutes will be perfect.
great. I'm gonna come back to questions then, and I'm gonna power through the rest of the planned content.
Perfect. And
So
I'll queue up his question for later.
yeah, so set yourself up to test. Testing is so important. You need to have a plan for how you're going to collect test results in a structured way so that you can compare results across changes. The thing that slows down our development the most is after we've built the feature, deciding whether or not it's good enough to release by testing it. Part of that is that because our model is so large, we really believe in full-scale testing. So we use PPU a lot, but we also have a inactive second full-scale ASCU that we can spin up to run full-scale tests. Like, I'm not afraid to spend thousands of dollars running a set of tests to find out whether a change impacts performance. If your model is under 50 gigs, like, you should just be able to use PPU. It's really only once you start to go beyond that that you really may need to have a big setup. And this was the real reason that we love Power BI for large models over AAS, which is you pretty much just have to pay for a test environment in ADX or in Azure Analysis Services. So I'd say this is like the most important thing to having a large model. We talked about this at the beginning. We have this fact table where it's super wide. We have another design where we have way fewer keys, but we have the keys broken out into a snowflake table. I guess this is what we talked about at the beginning, and then here, we have our slow changing dimension broken out into a changing into a like we have snowflaked out our slow changing dimensions, and like this drops the cardinality, or it has made this fact table way skinnier. It's only got 4 columns instead of dozens, but because cardinality has shot so far up, it's just way slower. And you might get that out of the book, but you might not. So anyway, that's the material that I planned. So let's dig into some of these questions. So let's start with Alex's question, because I suspect that's what you've got queued up next.
Yes. So let me go ahead. Up here we are. Then.
Yeah.
Perfect.
Okay. So the first thing I want to do is I want to make a book recommendation. And I'm blanking on the name of the book, but I'm sure Alex Powers will put in the chat. But there's this, it's called Lean Customer Development. And this is a great book if you are a PM, if you're a BI developer, on how to ask your customers questions to have them tell you what they want. And this question comes right out of the book. And so if you do anything with the CAT team, or Matthew Roche, they'll ask you this question, and this is their way of trying to get at what's your real pain point. Now, maybe explaining all of this ruins the question, and I'm sorry, Matthew, but it's interesting on its own. So that's that. So anyway, if I had a magic wand, what would be the one solution I would implement in Power BI to make my job and life easier? And actually, I'm going to change this to make my user's job easier, because when I describe my job is to make my user's job easier. And so that's really what I'm focused on. And for me, what I really want is I want to be able to define the tabular model in my data warehouse. And so anytime somebody imports a table, they get all of the measures that can be validly described with tables they have imported. So if somebody goes and imports 3 tables from my model, they will get, if they import the date table, the customer table, and the revenue table, they'll get the relationships and the measures and the RLS associated with those tables. That is what I would love to see. It would make it so much easier for people. When we have an enterprise tabular model, it makes it the questions that can answer out of the box are so easy to answer that your analysts aren't going to spend most of their time on them. They're always going to be spending time on the things that are hard to do. And that means that they're going to need to build some sort of import model to work around whatever your enterprise model doesn't do well, because that's what's hard. And that means they're having to recreate all the stuff that you already built. So if they could just import that with their data, then they could actually focus on what's different and special about their project, instead of trying to recreate all of this stuff that we have spent hours and hours trying to build out. So that's my magic wand item. I know that Alex has heard me say that before. And I really, really hope that with Kim owning Power BI and Synapse that this will come. But I don't know. I don't know.
To be determined.
Yeah. So that transitions to a question that was further back in the chat that I wanted to get to, which is I think it was from Matthias. It's do you really need a model this big? Can you break it up into smaller models? And I'm going to flip back in my slides to the beginning of the presentation. What we found is that almost every question needs revenue or performance data of some sort. And so while yes, we could have a version of the model that doesn't have the opportunity data, and a version of the model that doesn't have the performing customer data, and a version of the model that doesn't have the CRM data, they'd all have this core revenue data. And that's not a very compelling, like, oh, we made, instead of having one 80 gig model, we have 40 gig models. Like, that's not super compelling to me as a performance enhancement. Now,
Well, then
absolutely,
it becomes management too, because
yeah,
it's, I mean, if you're repeating the same fact table again, then and
yeah,
in theory, like, and also I think this was built at the time when there wasn't as many options for composite models, especially direct query against analysis services and Power BI datasets. The gigantic mouthful title that is.
yeah. That feature didn't exist. Now, I will say that feature is very dangerous. Um, we do use it, but
Mm-hmm.
very specifically. And every time it comes up, I always give the same demo, which is that if you bring in some Excel table that you want to mix with the core model, if that's a dimension table, it works great. You turn that into a fact table, turn that relationship around the other way, and your query just errors out. Because our dimensions are bigger than 1,000,000 rows, if you need to pass a filter from a dimension table in Power BI to the local imported fact table, it doesn't know that your fact table only has a dozen rows, so it just tries to pass all the dimension values, of which there are more than 1,000,000. So you hit the 1,000,000 row intermediates and you error out. So
Gotcha. Okay.
that
Okay.
feature is so dangerous because very subtle changes in your requirements can cause you to go from, oh, this works great, what's the big deal, to this never works, I don't understand, why is it so bad?
Yeah.
And so yeah, that feature's a bit scary, but it's true. It wasn't even an option. We had some interesting ideas. Another reason we built a PBIX is I was thinking that we would, coming back to like my magic wand answer, I was thinking we would like keep a current version of the PBIX and add some parameters so you could like build a 1 gig version of this model. You'd get all the relationships, you'd get all the measures, but like it would like turn off fact tables and like do some aggregations so you only got like a compact version of the fact, and you could have like a PBIX. But it turned out keeping those, there was a whole bunch of problems with doing that. Maybe with PBI tools it would be practical, but we never went down that road. And composite models is like sort of kind of solving that problem, which is like, hey, I wanna add one thing. What do I do? But that said, we do have separate models. My team doesn't own them, but like, for example, for us anyway, I don't know, for other people, big news this summer is that Netflix is adding an ad-supported tier and Microsoft is the exclusive ad sales partner. So we've got this new
Nice.
business, Netflix, selling ads for them. Well, it turns out that data is totally unrelated to any of these dimensions or fact tables. And so it's in its own model. It's great, because like, why would you put them in the same model? They're not related. In the future, that might change, but because we've sort of been bootstrapping this thing up, like it's not using the same tools. It's also like sort of run out of an acquisition that we made. Anyway, it's like splitting the model. Like you need to have a theory about like what are users going to do with this other model. We discuss this all the time. So there's another question in the chat from Donald, which is any
Yes.
RLS speed problems with your large models? The answer is yes, RLS. Are there speed problems with RLS? Yes, it's slower. And for us, it's slower in part because the dimension that we have RLS on is a many-to-many relationship. It's like a sales assignment dimension, and we have multiple sales functions in a sort of complicated way. So you can't just like build a table with a column for each function, so you end up with one person per customer in each column.
Mm-hmm,
You
mm-hmm.
just, there's multiple, like, okay, Amazon spends God knows how much money on us. Like, they have multiple salespeople in one role. And we have an account executive, an account manager. We have something that's sort of like a technical account manager. It's actually like a data salesperson. Like, all they do, we call them analytical leads. All they do is build data for customers. Because it turns out that the ad business is very data driven. Um, we have
Makes
partner
sense.
managers that work with agencies. Like, there's this whole complicated matrix of salespeople. And so we have the many-to-many relationship on assignment, which is what drives RLS on quota. Fortunately, the quota dimension is very small. You can see it just sort of peeking up, or the quota fact at the bottom here. It's very small because setting quota is a lot of work. So we don't do it on as many dimensions as other stuff. But it definitely causes performance issues, and but also, like, rules are the rules, and you just got to live with it.
Very fair.
Is don't over secure your data. Like, you might say, hey, let's make it so people can only see the revenue for their customers. And we just totally kibosh that. Like, quota secure, revenue's not. Anybody can see the revenue of any customer. And part of that's just because that's how some other tools work, but also it's like, hey, the RLS that like sort of mostly works on sales revenue, like if I applied this to monthly revenue, like the whole thing would fall over. And so, like, you need, like, I know in the security field, there's like a lot of folks that say like, hey, let's do least permission. And like, what you should be asking yourself is like, why should each person have access to this? And I think in the data world, for a number of reasons, you should be asking yourself, why can't people access any given point of data? Now, that's not true for all data, but like for broad BI data, like, how many customers do we have? Like, how much revenue do they generate? Do they generate support tickets? Like, my strong view is that data should be broadly accessible in your business. And the big reason for this is that your employees are smart, clever people that solve problems. And if you give them the tools to come up with creative solutions, they will. And you get lots of people that, do fun things with Excel. And, I think a lot of us came from that background of, having a problem in some business unit and you just like hack up a solution. And as a central BI team, our job is to encourage that type of, because we're not directly making the business better. Our job is to make it easier for people to do that. And so we shouldn't be fighting them when they're trying to come up with some clever way to, save 10% on the support process. So
15 minutes can save you 10% or more with Power BI.
Yeah, exactly. So that's sort of my spiel on RLS. I thought I saw one more question, and then we can maybe wrap up. Oh, yes. Why use fact?
Yeah, here we go. Boom.
Those are just typos. I will talk a little bit about our naming scheme in this setup. So in our data warehouse, dimension tables are prefixed with dim. Fact tables are prefixed with fact. In Power BI, we flip that around. In our data warehouse, we don't have spaces, we don't have capitals in our names because, the tools don't really support that, and nobody wants to escape their column names in SQL. But in Power BI, like, that's sort of the default. So we put fact at the end of our tables to help us, but all of our fact tables are hidden to the users. We use measure tables instead, for the most part, partially because with our like aggregation approach, we have measures that go across multiple fact tables. So it's just like, makes more sense to give them a shared place to live rather than say like, hey, all of the measures are going to go in this fact table. It also just gives us a little more control over the names of folders or measure tables. But we strip the dims out because we don't expect our users to have a Kimball background in Power BI. But in the data warehouse, we sort of do expect them to like know what a star schema is and think about these are dimensions and these are effects. But the dev team is in India, and not all of them have English as their primary language, but more importantly, they're 12 hours apart from me. And so I only get to spend so much time with them. And so as much as I feel column names are super important, sometimes we move on and I don't give them a hard time about typos. We slowly try and fix them, but it doesn't always happen. And once you name an object in a database, changing it is a pain in the butt. So that's where we are.
I agree.
Fortunately, changing names of objects in Power BI is way easier than any other database. Like they've done a lot to make it so things just automatically fix. But it always makes.
Do you remember? I mean, I remember back in the day, long time ago when I was a child. In Excel, that was not always the case with the Power Pivot model with VertiPack. Like the first versions of that, like if you needed to change a column, the measures would not inherit it. If you had like 30 or 40 measures that were all like it's like my first year, I self-taught myself, honestly, most of the stuff like through videos and other things. But I did one of those pitfalls where a lot of my measures for various spins on like sales calculations, you like calculate blah, it would be calculate sum of sales, but like in 25 locations. So it would just be the sum of sale. I didn't quite know yet my first, I'd say 6 to 12 months of Excel, like in 2010, with that to know to use a core measure for total sales and then reference that. But you change the column name in the model, that's like 40 measures that you have to go update because they all break. They didn't update. So Power BI thankfully does it. You rename a column, you rename a table, as long as it's the same back-end like identifier to it. Everything it automatically propagates those changes to all the related stuff in the visuals. They don't just disappear. In Excel, in Power Pivot, like if you rename a column, it disappears from all your pivot tables and it breaks all of your measures. It was a nightmare to deal with. So thankfully, as you mentioned, Power BI is really, really good about being agile with that stuff.
Yeah, it is. And in fact, I don't fully understand how it works, but in the last year, we've started to see these lineage tag fields in the BIM file.
Okay.
My understanding is that these help DQAS models track changes across too. I could be wrong. I haven't really played with them, but you start to see now in columns you create, there's like a lineage tag with like a little GUID in there. So
I like that.
Well,
there you go. I think this has been fantastic. I'm also really appreciative of the conversations that we've had, and I think there's a lot of really good questions. I do see one more question up from Craig. I think we'll use that to kind of be the last one and then wrap up officially. But how is Power BI changing the age-old idea of business versus IT conversation? The product has meant to address that question. Is that correct?
So, yeah, this is a great question. And I would say that Power BI does enable some changes to that division, but all hard problems are people problems, and this is a people problem. And like the way you solve this problem is by changing in your heart, not by using a different tool. That said, if you want to buy Power BI as part of changing the culture, like that can definitely be effective, and highly recommended that you buy Power BI. But I think definitely making it easier and more approachable for business users to build reports makes it an easier sell. But if you go talk to your salespeople or you go talk to your operations people, it turns out there is no amount of pain and suffering that they will go through to get the data they need to do their jobs. Like the amount of crazy stuff that the sales team does in Excel or that the ops team does in Excel to do whatever they need to do, routinely blows your mind, right? And like this is how so many people in our community became really good at Excel, is that they were doing some random job, and it turned out that if they built the mother of all Excel macros, like their job was 10 times easier. And then they found out that they could make more money making Excel stuff than they could doing whatever it is they were doing before. Like, we've all been through that journey. And I strongly believe that as IT folks, now that you've all gone through that journey and you're working full time in business intelligence, like, your job is to encourage and support that behavior, not to shut it down. And I know that's scary because, the flip side of that conversation is you think about those crazy Excel macros and those first power pivots and those first Power BIs we all made, and they were all awful. And we all know we can make things 1,000 times better now. Well, yes, but those first ones probably had more business impact than than the things you did later, because
fair.
They came from a real place of business empathy, which is to say they were very strongly tied to what the business actually needed to do. And so I think at IT, we always have this really big problem of, I've definitely gone through this where I started out, I was working in the business, I was really closely tied to some specific business problems. And now I work in IT, I don't build reports, and I have lost some of my empathy. And like, I'm much more like, this is the way it is, like, this is the strategy. And like, so as an IT team, I think it's super important to constantly be hiring from your users. So you're renewing that well of user empathy. So yeah, that's probably the biggest thing I like to talk about.
I'll bring this back up just so we can have a little bit of a larger screen for us as we wrap up. But yeah, this has been really great today. I think I certainly, I love seeing big, large models and then see people's practices for how they account for all of these little nuances. Because most enterprise models are not simple, and there's a lot of roads to home, so to speak, in terms of how to configure it. And the thing that I continuously say in every one of my trainings is model design is a mixture of art and science. Like, there is, the star schema is something you aim towards, but you're probably not going to have a perfect. I'll just say you will not have a perfect star schema if you are actually building a enterprise-sized model. You'll have things aiming towards that, but it's really good to continuously learn and hear different perspectives and all the ways that people account for certain things that need to be done. Like, well, we would have done it this way, but essentially the refresh was timing out and it was impossible to actually do anything around it. So we had to go through this other method that technically isn't as fast for X, but it's solved for Y. So I think that those case studies and stories really do help. So thank you for the talk today and for the chat as well. Thanks everyone for all of the questions and everything. It was a very active and lively chat. Quite a few people are wishing kind of a happy New Year's and everything else. Given that, I do want to at least make a little cheer confetti for that, both for the New Year's and yourself. But Alex, this has been fantastic. And next time you have a new presentation, you're touring around, I'd love to have you back on.
Sounds good. I definitely have some ideas for more presentations, and this has been super fun. And Happy New Year, everybody. Happy holidays. And
and for the audience, we will see you in the New Year's. Thank you so much for watching. Please consider hitting that like and subscribe button. And if you want to help support this channel, take a look at our channel memberships or our merchandise store for cool swag. And last but not least, please consider sharing this video on your social media platform of choice to help our channel grow. So, until next time.